Hello, welcome to today's class. Today we have this challenge before us here. So to simplify the square root of sine to the power of 4 theta minus tan to the power of 4 theta. How? How do we simplify this? So if you're new here, this is Math Prowess. And if you've not subscribed, do it to subscribe so that you get all our videos once they are released. And once you subscribe, turn on the notification bell. Okay, so let's go ahead and solve this. Now, we take a solution. Now, from this, we have a special identity here. We just have to rewrite this part of the expression. Remember that our tan theta is equal to sine theta all over cos theta. Okay, so if you remember this, we want to bring that here. So this is going to give us here the square root of sine power of 4 theta, then minus sine the power of 4 theta, okay, all over cos power of 4 theta. Here we can factor out sine to the power of 4 theta from the system. How we do that? Yes, very easy. So if we do that, this is going to give us here of our sine power of 4 theta, then bracket 1 minus, here we're going to have 1 all over cos power of 4 theta with bracket. Now we can separate this out. So we can rewrite this as the square of sine power of 4 theta times, let's put this in bracket and put this in bracket, into our 1 minus 1 all over cos 4 of theta. Okay, so let's put this in bracket also. Let's close this with a square bracket. Now with this we have here, we take this of this, so we end up having our sine square theta into, so we have 1 minus 1 all over cos 4 theta. All right. Now with what we have here now, we got this all over 1. So we can find the LCM down. So this will end up giving us sine square theta, okay, into, here we're going to have here the LCM is going to give us here cos 4 theta here. Then we use this to divide this to give us cos to the power of 4 theta. Then times the numerator, this will now give us here cos power of 4 theta, then minus 1. I believe this is clear, right? Good. So what do we do next here now? Then we can rewrite everything we have here. So this is going to give us this sine square theta, okay, into our cos power of 4 theta minus 1, all over the square root of cos 4 cos to the power of 4 theta. We just applied the law of sword. Therefore, it says that if you have your a all over b, the square root of a, this is same thing as the square root of a all over the square root of b. This is sword. Okay, so that's what we just applied here to here now. So if we find the square root of this is going to give us the absolute value of cos theta. So this will end up giving us sine squared theta all over the absolute value of cos theta, okay, into what we have here, cos to the power of 4 theta minus 1. We'll head it somewhere from here. Okay, now what we want to do, I want to rewrite this cos to the power of 4 theta. So we can rewrite this as, so this is going to give us sine squared theta, then all over the absolute value of cos theta, yeah, then into our cos square theta close bracket all to the power of 2 then minus 1. This one could also be written. And what can you see from this expression we have here now? This is difference of 2 square, right? Good. What does it say? Look at it here. It says that if you have your a to the power of 2 minus b to the power of 2, this is equal to a plus b close bracket, then bracket open a minus b close bracket. You remember this? This is called difference of 2 square. So we can apply that here also. So let's apply it and see what this gives us in turn. So we're going to have this to be sine square theta all over the absolute value of cos theta, right? There into the square root of our cos square theta plus 1 close bracket there into our cos square theta minus 1 close bracket. I want to write this expression I have here now. Bringing this out first. So this could be written as, let's still manage the space here. We have here sine square theta all over the absolute value of cos theta. Okay. Yeah. So yeah, bringing this out, said I want to rewrite this as the minus 1 into the 1, then minus cos square theta close bracket into here this will now come in now, which is cos square theta plus 1. Check this out. Has this changed anything? If I use this to open up this expression alone, it will give me this back again. Okay, so let's continue. Remember the trigonometric identity, which says that your sine, let's write it here, sine square theta plus cos square theta is equal to 1. You remember this? So if we make sine square theta the subject of formula, this is going to give us sine square theta is equal to 1 minus cos square theta. Okay, so what do you observe from here? Look at what we have here. So I can replace the whole of this with sine square theta. Okay, so let's go ahead and do that. This is going to give us something special. So we have here sine square theta all over the absolute value of cos theta. Yeah, okay. Then into the square root of our minus 1 into sine square theta, right? The close bracket into our expression is still here, which is cos square theta plus 1 close bracket. Okay, are we learning something from here? Easy. Okay, now we can bring this out again and push this in. So this will give us sine square theta all over the absolute value of cos theta. Okay, then into our sine square theta here in bracket. Then we have our minus sign here. Then let's bring this first to our cos square theta plus 1 plus bracket into our minus 1. So let's put times minus 1 here. Okay, something sweet is playing out here. We can separate each of these quantities here. So this is going to give us sine square theta all over the absolute value of cos theta then into our sine square theta. Let's keep this separately. Then into cos square theta plus 1 the bracket into its whole square bracket, then into a minus 1 the bracket with square bracket. Okay, so I just decided to separate each of these ones here. All right, so we go again. So what happened? this will come out of the system because this will cancel out this. So this is going to give us here sine to the power of 3 theta all over the absolute value of cos theta. Then we are left with this and this. So let's bring this up first. We have here this of minus 1 into, put this in bracket, into this of cos square theta plus 1 close bracket. Now recall that the square root of minus 1 is equal to I, imaginary, which is iota. So we can bring that into the system, okay, to take the place of this. So if we do that, we're going to have this to be our sine to the power of 3 theta all over the absolute value of cos theta here, then bracket our square root of cos square theta plus 1 close bracket iota. Okay, this I please iota. So we have to bring this one up first here, bring this one this way first. So in all, our answer now give us here the sine of power of 3 theta all over the absolute value of cos theta, then bracket our square root of cos, sorry, let's start with 1 of 1, then plus cos square theta close bracket or into our square bracket our I. All right, so this is the end of this simplification. All right, so if you learned something from this video tutorial so far, give the video a thumbs up. And if you are not clear in any of these steps, then drop it in the comment section. I'll there to reply to your comments. Remember, this is Math Prowess, and we all here loves you. Thanks for being there. Keep watching Math Prowess, even as we set to roll out more solutions to problems in mathematics. Bye.